Hello, this is a presentation for the Deque project. My name is Mayao and I'm from section AB. The first deliverable is finding the bug in the array Deque. My hypothesis is that when you use the increment method to access the first element, the program shouldn't say index out of bound. In other words, if the front equals to the last index, which is 15 in here, it should return 0, not 16. Before I debug, line 162 and 165 is passing in size into this method. So instead of comparing 15 against 16, which should trigger some if condition, it should return 0 instead, and then we'll be able to access -2 over here. They were comparing 15 against 3, which incremented 15 into 16 and causes index out of bound because there's no 16 in the actual array. For clients, the size should be equal to the number of elements in the array. So 4, 4, and 3, 3 after we downsize the array. And for implementer, the first element should be stored at index front +1, and the elements in the very back should be stored at back -1. For the first code trace, I first incremented size by 1 to tell the client there's one more element in your Deque. And then I created a new node that is type of node with E is specified by the client. And then we're passing in -1 as element. So this is the value that the node is storing. Then for the previous pointer, I'm pointing at front. And then for the next pointer, I'm pointing at front.next, which in this case is 0. Then we need to fix the pointer. So front.next.pre refer to this pointer. So instead of pointing at front, we're pointing at this element. Then for front.next, which is this pointer, now we're pointing at -1, the new node instead. For the second code trace, remove first. If it's equal to 0, then we should return null. There's nothing to be removed. We decrement the size for the client's sake to keep the invariant. We store the element to be removed into this local variable. We'll return it later. We change this pointer to point to front.next instead. And then we change this pointer to point to front instead. And now -1 should be eliminated because nobody is pointing it. Finally, we return this local variable we stored. Similarly, for the add last, we first increment the size to keep the invariant. Then we create a new node, passing the elements we pass, in this case 5. For the pre pointer, we point to back.pre, which is 4 in this case. The next pointer point to back. And then we fix the relationship. Back.pre.next is this pointer. Instead of pointing to back, we point to 5, the newly created node. For back.pre, instead of pointing at 4, we point at 5 instead. Then for remove last is the same. We decrement the size. We store 5 into a local variable. And then we back.pre equals to back.pre.pre, so this pointer point to 4 instead, and then back.pre.next is this pointer, it points to back instead, and then 5 should be eliminated by the garbage collector. Finally, we're doing a syntactic analysis comparing between array Deque and array list Deque. So the best case of add last would be theta of 1. Because the best case would be there enough room in the array and we don't need to do any resizing. From the code, we can see it would just be, we're not entering in this if case. So we only have 3 steps and they are not dependent on the input size. We assign the element to data index back, we increment the back index, and then we increment size for the client to see. The worst case would be theta of n. This is when the array is too full and we need to create a new array to copy all the elements in order. That involves a for loop, as you can see over here, which would be dependent on input sizes. For the remove first, The best case would be we don't need to do resizing for the array. We also don't need to do shifting because for the array implementation for the deck, all the elements stay as they were. We're only changing the front and back pointer. For the worst case, there are two little elements we need to downsize the array to save memory. Yeah, so we enter this for loop and it's dependent on input sizes. Finally, for array list implementation, for the best case, the array list has enough room in its internal array. Add the element to here and increment the size. Then for the worst case, the internal array is full. Then we would again do resize and it's dependent on input size. Finally, for remove first, the best case would be when the array doesn't need downsizing, but it would still be theta of n because when we remove something from the front, if we remove 1, then everything needs to shift left by 1. There's a for loop and it will be theta of n. For the worst case, the array needs downsizing. So we have two for loops going on. The downsizing, copy over the elements, and then shifting everything. But since they do it in parallel, they're not nested for loop, we can drop the coefficient of 2 for asymptotic analysis. So yeah, the worst case would also be theta of n. So that would be the end of the project. Thank you.